5, 4, 3, 2, 1, action!
Hello everyone. Thank you for attending our online seminar. You have heard this before, and I'm saying it again. COVID-19 has changed us profoundly. It changed the way we work, the way we think about and interact with our surroundings. While this has led to shift away from some of our existing market applications, there's always two sides of the same coin. New markets begin to emerge. Along with it comes new applications. LED display virtual studios have flourished over the past 2 years, thanks to the inability to move freely across borders. This growing demand allows us to create and continuously produce high-quality, immersive commercial films. As you can see at the beginning, a virtual studio can create a variety of scenes using camera tracking. The scenes can move with the actors to generate a highly immersive visual experience that breaks the boundaries of virtual reality. This year, we produced our online forum at Moonshine Virtual Production Studio in Taipei. Moonshine is our virtual production technology partner. Our use case is a representation of the growing trend. The increased preference, not to mention, accelerated by the pandemic, to expand virtual reality application in the LED display industry. In today's session, we have prepared many interesting topics to explore with you the new trends and the technologies in display application with a focus on the general LED display, mini LED, micro LED, and the LCD displays. I'm going to pass the time over to our product managers who will explain the exciting topics in further detail. Thank you.
Hello, my English name is Cloud. My Chinese name is Uida. I work on LED display driver ICs and LED backlight driver ICs with local dimming at Macroblock. You may have noticed an emerging discipline that combines the XR concept and LED display. I'm referring to virtual production. I will present an upcoming Macroblock driver IC designed for virtual production. For example, a display driver IC solution for high PQ virtual production. Given the current trends, I'll show you what specifications LED display driver ICs for virtual production need, the challenges, and how to overcome them. As virtual production evolves, we know some commercial and music videos, and even movies, are shot with LED display. The movie application uses LED displays as background to the people and objects in the foreground. What are the benefits? For example, background can be created in the studio with LED displays. It can be a desert at noon or during night. You don't have to bring the cast and crew to some Californian desert. You don't have to worry about weather getting in the way of shooting. LED displays offer the flexibility to create varying content with ease. How to create true-to-life background that doesn't look fake or isn't realistic enough or distorted? It has to do with issues that existing LED displays have not yet overcome. Let's talk about the needed hardware specifications for LED displays in virtual production applications. Let's start with the number of scans. There are a couple of key indicators for LED displays: pitch and brightness. First, we say P2.8 to P1.5 is the best pitch for virtual production displays because LED displays with P2.8 are bigger in size given the same resolution. For applications with big screens, they can completely cover the people and the objects, so they are ideal for backgrounds. P1.5 is best for close-ups. P1.5 eliminates the graininess as the camera focuses on the display. As a result, the industry mostly uses LED displays with pitches between P2.8 and P1.5. Brightness is important too. To reproduce true-to-life background, displays may have to support HDR sources with very bright and dark content. As the brightest scenes fall between 1000 to 2000 nits, they will be limited by LED display specifications, which have to do with scans and LED properties. To meet pitch and brightness requirements, Macroblock calculated LED properties for movie production. To figure out the number of scans for HDR brightness between P2.8 and P1.5, we found it's around 14 scans for P2.8 and 16 scans for P1.5 due to the latter's higher pixel density and higher brightness per square meter. It's not that we cannot use higher scans. It's just that we have to choose the right brightness for higher scans. Therefore, 16 scan is optimal for applications with the right pitch and brightness for virtual production displays. Cameras are also important for virtual production. Let's talk about a basic concept first. LED displays show the image. For a camera to capture the whole image, there are two things to consider. First, the camera and the display have to be synchronized. This can be achieved with the controller's Genlock function. Second, the frame rate of the display has to be a multiple of camera frame rate. That is, if we're shooting in 24 FPS, the display frame rate needs to be a multiple of 24 Hz. For example, 48 Hz, 96 Hz, etc. This enables the camera to capture the whole image. By the same token, the display has to show 120 Hz and even 240 Hz images if we use a 120 FPS camera. This is essential to avoid distortion. However, will meeting these requirements be enough? It's time to discuss the three challenges as we shoot LED displays during virtual production. They are motion blur, scan lines, and flickering due to low-gray refresh rate. Users are forced to fix and eliminate the problems during post-production, which incurs additional time and cost. Motion blur is caused by low LED display frame rate. These are taken in 60 FPS. The moving football to the left looks blurry as the display doesn't have enough frame rate, 60 FPS. We can see the football clearly to the left since the display has enough frame rate, 120 FPS. We see that if the display cannot support high frame rate, the image will become blurred. We need to increase the display frame rate to avoid the problem of blurriness. Our new driver IC solutions feature PWM Enhancement Plus, enabling 16-bit high grayscale display with 120 Hz frame rate for sufficient refresh rate. People, objects, and background can be clearly captured, eliminating motion blur. The second challenge is scan lines. Let's look at the image. A camera took the rolling dark and bright bands on the display. We call them scan lines. It's mostly caused by the difference in camera CMOS sensor and LED display refresh rates. Please refer to the video Common Shooting Issues with LED Displays for details. Since we cannot control the rate difference, we need to reduce and even eliminate scan lines. Our latest driver IC provides two solutions. The first method is PWM Enhancement Plus, which maintains the 16-bit high-grade display with 120 Hz high frame rate to prevent distortion. Most importantly, it provides an amazing 7,680 Hz refresh rate to minimize scan lines. With the second method, we developed the brand new hypervision calculation in response to the virtual production trend. Without the technology, the video to the left has the rolling scan lines in the darker areas. The video to the right has almost no scan lines, thanks to the technology. The third challenge is the lack of low-gray refresh rate. Low-gray areas flicker as the low-brightness areas don't have enough grayscale, preventing the capture of the complete image scrambled via SPWM. The valley area is darker. The low-gray flickers are very obvious. Please refer to our video, Common Shooting Issues with LED Displays, for details. How do we solve the problem? Let's take a look at the flickering caused by low display refresh rate in low-gray areas. If we can significantly reduce or eliminate the phenomenon in live shots, like the video to the right, we cannot see flickering on the display with hypervision calculation. The images look much more stable, which is a benefit of the driver IC with hypervision calculation. The solution for virtual production displays features a couple of our core technologies and more. 1. PWM Enhancement Plus eliminates motion blur and reduces scan lines. And 2. Built-in hypervision calculation eliminates scan lines while shooting a display, resolves the lack of low-gray refresh rate, and minimizes or even eliminates flickering with low-gray applications. The solution with hypervision calculation is a new driver IC, ideal for virtual production applications. It boasts the advantages that address the weaknesses of available driver ICs in virtual production applications, which in turn significantly cut post-production time and cost and give users peace of mind. That brings us to the end. Let's welcome the speaker, Mr. Hongyi Chen. Thank you.
Hi, my name is Chen Hongyi. I am the LED Driver IC Product Manager at Macroblock. I would like to talk about premium fine-pitch LED drivers to achieve HDR-Optimized performance by the highest scan design. As fine-pitch solutions penetration of the LED display market grows significantly, many new LED display solutions have hit the market. First, let's look at the relationship between LED pixel pitch and emerging applications. P1.2 to P2.5 mm is the most typical pixel pitch for available applications. Commercial all-in-one LED display is a new application that is more compact, as it combines a modular product with an integrated controller to reduce technical entry barrier for end users. It's also easier to install. Commercial AIO displays have lots of applications, such as commercial and public spaces, academic settings, control rooms and conference rooms, etc. Then there is the home theater application for mini LED. You can imagine bigger TVs, from 146 to 219 inches. As streaming platforms emerge, consumers want better display performance. LED displays provide consumers with a more immersive visual experience, thanks to the high contrast ratio. Micro LED displays are also for automobiles. Automotive displays mostly have to do with instrument cluster and central console control panel. While LCD remains the mainstay, micro LED panels excel in brightness. Drivers can clearly read the information under sunlight. With a resolution of 100 to 200 ppi, existing automotive display panels are quite readable. All these fine-pitch LED display applications need excellent performance. There are many process challenges to meet. Let's examine the technical challenges for fine-pitch LED displays and their driver ICs next. First is the LED chip size, which shrinks to 75 micrometers for micro LED from 300 micrometers for traditional. The smaller the size, the finer driving current of the IC. Then there is the LED manufacturing process. Most mini LEDs use flip chip packaging, eliminating the wire bonding step. Transfer is next. Transfer technology involves picking and placing LEDs on the board. Many LEDs generally use traditional pick-and-place technology that directly mounts the LEDs to the PCB. Mass transfer puts LEDs on the PCB with static electricity or laser before molding. Yield and manufacturing efficiency are the biggest challenges to mass transfer. The technology is still being optimized. The fourth key technology is the substrate. Most substrates are PCBs. The pixel pitch limit for PCB is about 0.4 millimeters. With sub 0.4 millimeter pixel pitch, mass transfer needs a flatter substrate. Glass is a good candidate as it's good for 0.1 millimeter. Silicon substrate may enable even higher PPI. PCB layer is the last key technology. Reduced pixel pitch leads to additional PCB layers, which increase manufacturing cost. Macroblock announced 64 scan products last year that effectively cut the number of PCB layers for certain pitches, such as P1.8 and P1.5. These factors show manufacturing technology and cost jump as the pixel pitch shrinks. What kinds of technical enhancements and improvements do LED driver ICs need? Macroblock announced the 16-channel MBI5264 high-performance solution last year. It's in production now. We announced the upgraded version MBI5265 this year. It features excellent display specifications and increases the number of scans to 96. The pixel pitch is reduced to P0.9 from P1.2. Sub P0.9375 solutions no longer require highly integrated driver IC solutions. Thanks to MBI 5265, 16-channel offerings can support P0.9 designs, saving cost while maintaining display quality for fine-pitch solutions. The figure shows the number of scans versus the number of ICs. For example, the number of ICs can be significantly reduced as the number of scans increases with 16-channel driver ICs in 1 square meter cabinet. The table shows available P0.9 to P1.875 solutions. Comparing solutions based on the 64-scan MBI 5264 and the 96-scan MBI 5265, when the X or Y axis of the modular resolution is a multiple of 64 to 96 scans, MBI 5265 can effectively replace existing products with 64 or fewer scans. MBI 5265 can slash the number of driver ICs used by 30 to 60%. MBI 5265 is a 16-channel driver IC supporting 96 scans and up to 16-bit grayscale. Since MBI 5265 supports high scan design, the maximum current can reach 30 microamperes to meet the same brightness of the module. Function-wise, MBI 5265 features PWM Enhancement and Grayscale boost. Furthermore, Macroblock incorporates the new uniformity driving into MBI 5265. Why do we need uniformity driving? Fine-pitch LED displays are very demanding of display performance. Macroblock coined the new basics, which are standards for fine-pitch displays that include picture quality, HDR-Optimized, and minimum gray. To meet the specifications, excellent display performance at low grayscale is the key. Lack of uniformity at low grayscale will hurt contrast ratio and hence details suffer. Color blocks and vertical stripes are the most common issues, which can be improved with the skew of the driver IC and timing function. However, increasing the number of scans leads to a new problem: horizontal stripes. You can see the horizontal stripes as alternating dark and bright bands on the board. What is the horizontal stripe? The figure shows the behavior model of the LED display. PCB layout will lead to small differences in parasitic inductance. When the current goes through the circuit, the parasitic inductance will cause LED anode voltage to oscillate. The variance between the current going through the LEDs sent by scans will result in horizontal stripes. The more scans supported by a driver IC, the more serious horizontal stripes will become. As the display increases driving current and speed of response to maintain the brightness and grayscale, inductor formula shows LED anode voltage oscillation will increase with the speed of response. Ultimately, horizontal stripes will be more visible with the high scan scheme. Finally, since MBI 5265 is embedded, the uniformity driving function can improve low grayscale problems caused by horizontal stripes. We can see in the MBI 5265 demo that when using the high scan design, display problems such as horizontal stripes, color blocks, and vertical stripes appeared on the module. By turning on the uniformity driving, horizontal stripes, color blocks, and vertical stripes can be effectively resolved. Display performance remains excellent despite increasing the number of scans. This applies to high-performance driver IC solutions with P1.8 to P0.9. We also have a high-performance driver IC solution for sub-P0.9 applications. That is the MBI 5864. MBI 5864 is a highly integrated driver IC solution. Supporting mini micro LEDs, applicable pixel pitch falls between P0.9mm to P0.4mm. The mass production of MBI 5864 will soon begin. Numerous verifications with fine pitch modules showed good display performance. MBI 5864 is a highly integrated driver supporting 48 channels with built-in 16-scan MOSIS. The driver IC supports up to 64 scans. Since the target brightness is very low, the driving current may be as low as 0.1 microamperes. Current is precisely controlled to within 1% of the target to improve display quality. Finally, MBI 5864 uses scan sharing technology that enables a driver IC to share scans with other driver IC's channels. This technology helps to reduce the number of driver ICs needed, given the same solution. As to the scan sharing technology, Macroblock already has a US patent for common cathode solution with the scan sharing scheme. You can search the patent number for more details. Let's have a look at two MBI 5864 use cases, including a P0.49 60-scan mini LED module and a P0.625 48-scan LED module. We can see the modules are tiny as MBI 5864 combines BGA package with scan sharing to reduce the number of driver ICs. Furthermore, MBI 5864 has broken through the existing pixel pitch barrier. It's easy to put it on the back of the P0.49 mini LED module, further streamlining the PCB layout. As far as display performance is concerned, MBI 5864 supports current as low as 0.1 microamperes. Color is vivid in the brighter parts of the image and detailed in the darker parts. Reduced pixel pitch enables MBI 5864 to provide even higher resolution, making it ideal for end products that are often viewed closely. Then we tested for the contrast ratio of the P0.625 LED module with a photometer. The ratio between the brightness and darkness parts was 25,000 to 1, as MBI 5864 supports 16-bit grayscale for the super high contrast ratio. Lastly, we measured the temperatures of the P0.625 module with an all-white image at 800 nits. We found a near consistent temperature of 35 degrees Celsius with the front and back ICs. Temperature is reduced significantly comparing to competing highly integrated fine-pitch products. This means with MBI 5864, the modules will not get too hot to impact display performance, such as cyan blocks or color shift, proving MBI 5864 is a stable, high-performance driver IC. Let's sum it up. Macroblock launched the first high-scan, high-performance display solution MBI 5264 last year. In 2021, Macroblock expands the high-scan scheme to sub-1 mm pixel pitch, including the 96-scan MBI 5265 and the 64-scan MBI 5864. All three products effectively lower driver IC counts and manufacturing cost with display performance of 16-bit, 3840 Hz refresh rate, meeting the HDR-Optimized target. These are Macroblock's high-performance solutions for fine-pitch LED displays. Thank you for your time. Let's welcome the next speaker, Chen.
Welcome to my presentation. I'm Chris from Macroblock. I'm honored to discuss how the mini LED backlights delight gamers. Consumers want clear and delicate images. When it comes to general-purpose display panels, they want high quality and high contrast. How about gaming display panels? In addition to the two properties, what do you think gaming display panels need? Let's look at the game clip. You can see the images move up, down, left, and right. It varies in speed, but the images remain fluid and stable. Therefore, gamers need gaming display panels with high contrast, high frame rate, and dynamic sync to maintain the highest quality for the ultimate gaming experience as images continue to change. When we see a movie or watch TV, the frame rate is regular at 24 FPS, 30 FPS, or 60 FPS, and the refresh rate is fixed. But when we play a video game, GPU doesn't have a regular frame rate. It's always changing to the complexity of the image. Therefore, gaming devices need to support variable refresh rate, VRR, to achieve dynamic sync that ensures perfect presentation of gaming images and avoids abnormal conditions. Let's look at the abnormal conditions of display panels without VRR. The first part is stutter and tearing for LCD display panels. And the second part is flicker and uneven brightness for the mini LED backlight. The first abnormal condition is stutter. Please observe the explosion and fireball in the video. Have you noticed the stutter during the explosion and fireball eruption? The video feels slow sometimes and skips some frames. It is far from smooth. This is stutter. Then there is tearing. Please pay attention to the mark. You can see the tearing as the image moves. The beam in the last frame should be straight, but is broken instead. Gamers are not sure if their aim is on target or not. This kind of abnormal condition is called tearing. Whether it is stutter or tearing, gamers hate it. They get so upset that they want to smash the display panels. Now let's look at the mini LED backlight. First is the flicker. Did you notice the image flickered? Sometimes it suddenly became brighter and sometimes darker. It's a mini LED backlight abnormal condition. The image showed unusual flickers. In addition to flicker, the mini LED backlight may not be uniform in brightness. Sometimes the upper part of the image is brighter, or the lower part is darker. This is uneven brightness of backlight. These abnormal conditions will greatly affect gamers' experience. To provide consumers with an improved gaming experience, it's very important to have the mini LED backlight with VRR. Having seen the abnormal conditions, let's look at what caused them and how to prevent them via VRR. Let's look at stutter first. You can see from the timing diagram that the LCD display panel shows one complete frame before moving on to the next. The frequency is fixed. The diagram shows while the LCD display panel finishes showing frame 1, GPU cannot generate frame 2 in time. So the LCD display panel will show frame 1 in its entirety again. After GPU generates frame 2, the LCD display panel will show frame 2. Since this gaming device uses the traditional V-Sync signal, not using dynamic sync, the image stutters. Just like the fireball we saw, it doesn't move smoothly. Let's have a look at tearing next. You can see from the timing diagram that the GPU sends the data of a frame to the LCD display panel immediately after the GPU generates it. However, the GPU doesn't generate frames at a steady rate. An LCD display panel with a fixed refresh rate won't be able to achieve dynamic sync. It will cause the LCD display panel to show part of the data from the old frame and part from the new frame, which results in the tearing you see during gameplay. A case in point is the broken beam, as the upper half of the image is from the new frame, while the lower part is from the old frame. To eliminate stutter and tearing, gaming devices need to support the variable refresh rate, VRR. The feature enables the refresh rate of the LCD display panel to match the frame rate of the GPU. As dynamic sync is achieved, the LCD display panel will be able to show every frame generated by the GPU one by one. We will discuss mini LED backlight abnormal conditions next, and how VRR overcame flicker and uneven brightness. First, I would like to ask you, do you know why the mini LED backlight without VRR creates abnormal conditions? It's because the mini LED backlight picturized the image shown by LCD display to be full array local dimming backlight. Therefore, the mini LED backlight shows patterns as one frame by one frame. Flicker and uneven brightness are caused by the mismatch between the mini LED backlight refresh rate and GPU frame rate. Without VRR, gaming devices cannot achieve dynamic sync to prevent the issues. First, let's look at the abnormal flicker of the mini LED backlight. Under static type, the V-Sync signal can arrive too early or too late. Let's look at V-Sync coming too early first. If the source sends V-Sync ahead of time, the data for the next frame will be sent as the signal comes in. The timing diagram shows grayscale brightness will change and the backlight brightness will go up, making the overall image brighter. Consequently, the source sending V-Sync earlier than it should from time to time will make the image flicker irregularly. With the VRR-enabled mini LED backlight driver, the backlight driver will put off the signal if the source sends V-Sync ahead of time. Data for the next frame will be sent only after the PWM duty cycle is completed. Therefore, backlight brightness is maintained, and the image remains normal without flicker. In a non-VRR-enabled system, if the source sends V-Sync later than it should, the timing diagram indicates the next frame will be sent later, lowering the brightness of the entire image. If the source does this randomly, there will be flickers. The mini LED backlight driver supporting VRR will solve the problem. The timing diagram shows the backlight driver will put off the V-Sync, while repeating the data from the last frame before showing the data from the new frame. Flicker will be eliminated as the driver adjusts backlight brightness. Now let's look at uneven brightness for the mini LED backlight. With the scan type, a scramble is scanned line by line from up to down while turning on the backlight. We will discuss what happened if V-Sync arrives too early and too late. We can see from the timing diagram of the 4-scan mini LED backlight that as the source sends V-Sync early, it will light up from the first line again line by line, so that the upper part of the display panel will be brighter, the middle normal, and the lower dark. For example, uneven brightness. If the source randomly sends V-Sync ahead of time, there will be all kinds of uneven brightness, as we see in the video. The mini LED backlight driver supporting VRR will solve the problem. The timing diagram shows the backlight driver will put off the source that sends V-Sync early, while it only shows the data from the next frame after the scramble for the previous frame is complete, thus preventing uneven brightness. What if the VSync lags? The timing diagram shows as the scramble lags, only the first and the second scan will be lit, while the rest stays dark. Therefore, the upper part of the image will have the right brightness, while the lower part will be too dark. So the brightness will be uneven whether the VSync arrives sooner or later than it should. Only with VRR can the mini LED backlight driver put off the VSync and repeat the scramble of the data of the last frame before showing the next, which effectively solves uneven brightness and restores the correct image. Now you know VRR is critical to LCD display panels and mini LED backlight, as it can match the speed of image displayed and the speed of image generated. VRR prevents stuttering and tearing and overcomes flickering and uneven brightness. Gamers can better enjoy the game as a result. Macroblock has been developing the mini LED backlight for years. To provide gamers with the ultimate gaming experience, we have announced mini LED backlight solutions for gaming. All the solutions feature VRR. Macroblock has MBI 6329 and MBI 6353 for gaming TVs and gaming monitors. MBI 6334 is a solution for gaming laptops, gaming tablets, and VR devices. Macroblock will continue to develop gaming backlight offerings. We look forward to the evolution of the industry and will work with other brands to continue to bring unparalleled gaming experience to gamers. Thank you. Next up is our Q&A session. Now, we welcome your questions.
Hello everyone and our friends in Europe. Welcome to Macroblock 2021 Online Symposium. I'm Alice. It's so good to see you all. The LED industry has grown and enhanced technology rapidly since the pandemic changed our life. And this year, Macroblock has cooperated with a virtual production company to have an innovative way to present our products. We hope you enjoy it. And today, we have discussed the virtual production and XR technology, high-scan solution, and mini LED backlight solution. It's not only into the LED industry, but also expand the new display generation. So now, let's invite our speaker, Cloud, Freddie, and Chris as the product manager to take the questions. Welcome.
Hello everyone.
So we have received many questions in our chat room. Before we start the Q&A section, I would like to ask our speaker who have joined the online symposium last year to tell us the shooting experience of the virtual production. So Cloud, last year we also have the online symposium, but in the real scene. Could you tell us the differences between this year?
Okay. It's been an honor to be able to participate in the shooting using virtual production technology that even actors don't have this experience. To be honest, compared to the usual green screen with an empty background, the background has rich content and light and shadow effects, which are easy to feel immersive. The content and location of this lecture is very easy to imagine and master, and I think it can effectively reduce the adaptation time of speaking on stage.
Thank you, Cloud. And same question to Chris. Could you share the shooting experience of the virtual production?
Yes. This time, I deeply felt the convenience of using virtual production to film the symposium. The real-time backdrops and the visual effects are all on set. It just takes a few minutes to change scenes. That can shorten the post-production time. And also this time we also used real-time camera tracking. The backdrop is synced with the camera. So for example, the camera is shooting with the angle of 45 degrees. So the screen of backdrop is also shown the same field of vision with same degrees. It's really amazing.
Thank you, Chris. And we have moved from the real and virtual scenes into reality, that our audience have an immersive experience in the virtual production. So now let's get into the Q&A section to understand more about virtual production technology and our VP solution. Let's bring back our speaker, Cloud, to take the questions. Hello, Cloud.
Hello, everyone.
So, Cloud, the first question is, can virtual production solution solve the flickering issue when shooting by iPhone 240 FPS, slow motion cameras?
Okay, so first of all, as mentioned in the speech, the basis of flawless shooting is that the LED display and the camera must be synchronized. This requires a Chen function in the controller of the LED display. So it is not easy to capture flickering and scanning lines. With the Chen function combined with our hypervision calculation technology of our VP solution, the flickering phenomenon could be solved at low grayscale.
Thank you, Cloud. And which driver IC can support the lowest scan design in pixel pitch 2.6 millimeters for virtual production?
Okay, generally speaking, under P2.6 condition for virtual production, to achieve the brightness and display performance by NBI 5264 is 8 scans. However, our VP solution can achieve the same brightness and display performance by using 16 scans. The definition of display performance here is 16 bits grayscale with high refresh rate under 120 FPS.
Thank you, Cloud. And next question is, as keeping a 16-bit grayscale, does Macroblock have a part that can achieve over 3,840 Hz refresh rate?
Okay, with fewer scans, NBI 5264 can also achieve more than 3,840 Hz refresh rate at 16-bit grayscale, while the VP solution has PWM Enhancement Plus, which can maintain 16 bits grayscale under 16 scans conditions and provides 7,680 Hz refresh rate, which not only can effectively solve the scan lines, also can better solve the flickering phenomenon at low grayscale.
Also, Cloud, we have noticed that there have some technical terms we are not familiar with. Could you describe each term to let us know the differences?
Sure.
So the first one is, what's the differences between PWM Enhancement and PWM Enhancement Plus?
Okay. PWM Enhancement is to support 120 FPS high frame rate and can gauge 3,840 Hz refresh rate under 16-bit conditions, while the PWM Enhancement Plus is to get 7,680 Hz refresh rate under the same conditions as above.
Wow, it seems like PWM Enhancement Plus can achieve 7,680 Hz to have a better visual performance. So next one is, what is Grayscale Boost Mode?
Okay, the Grayscale Boost Mode can achieve higher grayscale than previous NBI solution, which has no Grayscale Boost Mode, under the same clock frequency.
Okay, so sounds great. So what is the hypervision calculation?
Okay. Calculation can solve the shooting problems that often occur during virtual production shooting. First, it can overcome the scan lines, and then it also can solve the flickers.
Wow, this technical terms is very important for the virtual production to solve the flickers. So thank you, Cloud, for letting us know more about virtual production and our VP solution. We expect it to release this product soon. So let's move on to the high scan solution and bring back our speaker, Freddie, to take the questions. Hello, Freddie.
Hello, Alice. Hello, everyone, and some old friends.
So, Freddie, the first question is, can NBI 5265 achieve 16-bit and 3,840 Hz refresh rate and 96 scan?
Okay, I think the answer is positive, but we look at the main feature of MBI 5265. The first one is embedded PWM enhancement. The second one is Grayscale boost. The last one, the third one, is uniformity driving. Especially last two features, make the display possible, and also is the main difference compared to MBI 5264. That's make your display can run with 16-bit of grayscale at 96 time multiplexing.
Oh, it seems like this customers has used Macroblock driver ICs MBI 5264 before. So Freddie, could you tell us what's the differences between MBI 5264 and MBI 5265?
Good question. I'll put in two ways. The first one is the user right now using MBI 5264. If you put MBI 5265, you are going to have the same performance, the visual performance, 16-bit output grayscale at 4K refresh rate. The second is you can even drive more LED due to its support more time multiplexing, or you can squeeze your pixel pitch a little bit smaller. You can get the same visual performance.
Thank you, Freddie. So next question is, except for MBI 5265, do Macroblock's other driver ICs have the uniformity function?
Well, I think MBI 5265 is the first product we implement low grayscale uniformity driving function. Indeed, of course, it runs very well in some of our early adult customers. So in the future, we are going to realize feature in our future products, especially in the indoor application.
Thank you, Freddie. So next question is, what has been updated for MBI 5864 new version?
All right, I think the video has tried to deliver 2 points, and it is important. The first one is low current precision control. The second is low power consumption. For low current control, for the indoor application, you can see that the solution, the driver solution, only provides 0.5 milliamp for the lowest current output, with the current accuracy at 1% to 1.5%. But for MBI 5864, the minimum current output is 0.1 milliamp, which is 100 microamp. And the current accuracy is 1%. So as you can imagine, the total performance, the control ability is 5 times better than the previous product. And the other, for low power consumption, as we have demonstrated, one module with 0.625 pixel pitch running with 800 nits of brightness. As you can see, the working temperature is around 40 degrees Celsius. I think this is a good performance or demonstration for the customer. Once you choose MBI 5864, you are going to reduce your heat wave of your display.
Wow, it seems like it's quite challenging to have 1% of precision accuracy in 0.1 milliamp. So next question is, there are many common cathode driver ICs on the market at present. So what's the plan of Macroblock for the future small pitch common cathode?
All right. Well, Macroblock got a US patent granted this year. So what are the products applied with this technology? The first one is MBI 5754. The other one is MBI 5759. So choose this product, you are going to have 16-bit of output grayscale. Well, it's a vacancy, worse. In previous, you don't have such a product you can buy from the market. Now you have. And in the future, we have a lot of solutions and selections for the common anode solution. We are going to implement this pattern technology for the different pixel pitch and the different application. So please help me to list these two pattern numbers in the chat room.
Thank you, Freddie. Macroblock has optimized the driver IC's function to lead the LED industry to the next level. Furthermore, we have some questions related to mini LED backlight solution and Metaverse. Let's bring back our speaker, Chris, to take the questions. Welcome, Chris.
Hi, Alice. Hi, everyone. I'm Chris.
Okay, Chris, the first question is it necessary to have VRR function for Metaverse applications?
Yes, Metaverse is the most popular topic recently. It's an interactive virtual reality. So the display is shown with the surrounding people and the surrounding scenes. So the frame data of display should be calculated immediately. Therefore, Metaverse display devices must have VRR. Otherwise, the abnormal, like I mentioned in the symposium, stutter, tearing, flickers, and the uneven brightness may happen. So for Metaverse wearable devices, NBI 6334 is a suitable backlight solution. So, and the Macroblock will announce more new products for this field in the future.
Sounds great. I believe NBI 6334 will be a popular product for mini LED backlight applications, and we are excited to have more new backlight products. So Chris, the next question is, as for gaming monitors, having high frame rate is necessary. Do Macroblock's gaming backlight products support the high frame rate? And also, what's the VRR frequency of the Macroblock backlight products?
Yep. Macroblock's mini LED drive IC can support up to 480 Hz frame rate. The mainstream of frame rate in gaming LCD is 144, 165, and 240 Hz. So how about the backlight? The frame rate of backlight depends on scans, refresh rate, grayscale, and whether it has VRR function. So in normal design condition, for scans, 3840 Hz refresh rate, 12-bit grayscale, and with VRR function, Macroblock mini LED drive IC can support the frame rate up to 480 Hz to fulfill the required spec of a gaming product.
Thank you, Chris. So next question is, how about the display applications in Metaverse?
Yep. Metaverse display devices also request high frame rate to make video smoother. So Metaverse display devices request not only VRR, but also high frame rate. So when we play in VR device, sometimes we feel dizzy. Part of dizziness is coming from the motion blur of LCD. So there are two solutions to solve the motion blur. First is to increase the frame rate of LCD. Second, to implement black frame insertion in backlight. So for black frame insertion, as I mentioned, the frame rate of backlight is 480 Hz. The frame rate of LCD is 240 Hz. So we can take the advantage of high frame rate of backlight to implement black frame insertion to reduce the motion blur, then to reduce the feeling of dizziness.
Thank you, Chris. So next one is well scanned.
Yeah. Basically, flickers are caused by PWM. So no matter scan type or static type, as long as it adopts PWM dimming, that will cause flickers. So even traditional edge-lit backlight may have flickers. So, but it could be solved. It could be solved with high refresh rate. The refresh rate of Macroblock mini LED drive IC can reach over 20,000 Hz, which can pass the flicker-free certification by the third party.
So Chris, is it the same as VRR cause the flickers that you mentioned in the video?
Yep. Flicker caused by PWM dimming and the flickers caused without VRR are different. Flickers caused by PWM dimming is because PWM duty high and low makes the backlight bright and dark. So the solution is to increase the refresh rate to solve flickers. Flickers caused without VRR is because the mismatch of the refresh rate of backlight and the frame rate of GPU. So the solution is to adjust the time of next frame to solve flickers.
Thank you, Chris. So VRR and high frame rate will be the main factor for gaming applications. And we believe with a high frame rate up to 480 Hz of the high standard in the mini LED backlight gaming industry will let our customers to have a better visual performance. So we still have many questions in our chat room. Our member will keep replying to you. You may also contact our sales representative after the live. Also, if you would like to watch our video in the future, you may search Macroblock's website and YouTube channel for the playback, and follow our linking for more information about our products. So it's all for today, and thank you for joining us. Christmas is coming. We wish you a
Merry Christmas
and
and
Happy
Happy
New
New
Year.
Year.
Looking forward to seeing you soon. Bye bye. Thank you.
Bye.
Bye bye.